and welcome to class. In this video, we'll be continuing our study on binomial expansions. Remember that in the previous videos, we've had to look at binomial expansions using Pascal triangles. And in this video, we want to consider how also we can expand binomials using the concept of combinations. All right. So now you might be wondering, what is a binomial? Of course, the word bi means two. So binomial is any mathematical expression that has two terms. In other words, something like this, your a plus b is a binomial. So binomial deals with how we can expand things like this, things that have two terms. When there are more than two terms, like your 3 times 4 and all that, you begin to have polynomials. So binomials deals with how we expand things that have just two terms. All right. Okay, now we want to go into this, but before we even start, we want to run a refresher on the concept of combinations. Remember that we have had to study combinations, and if you remember, your combination is something like this. Is the general formula for your combination, that when you are to make a selection from an n, the total person, you have your n, and then you want to select a number r from the n. The combination, the formula for that n combination r is given by this that we have here. Okay, it's given by this, that is n factorial over n minus r in bracket factorial, then of course your r factorial. So a very quick example, if we want to evaluate 5 combination 3 factorial, to want to evaluate 5 combination 3 factorial, following this formula that we have here, our n in this case is 5 factorial all over, then we have in bracket 5 minus 2. Okay, let me go ahead and write that just for it. 5 minus 3 factorial, then of course we still have an r, which is 3 factorial. Now going further, we have 5 factorial over 5. Okay, 5 minus 3 now, that will give us 2 factorial, and then we'll have still 3 factorial. Remember that your factorials, your 5 factorial means that you have to multiply from 5, you decrease in steps of 1 till you get to 1. So that means that 5 factorial means 5 times 4 times 3 times 2 times 1. 2 factorial means 2 times 1. 3 factorial means 3 times 2 times 1. Okay, this is just a refresher. So for us to simplify what we have here, we go ahead, 5 factorial, that is 5 times 4 times, of course we have still 3 factorial, which will replace your 3 times 2 times 1 and all that. So all over, we'll still have our 2 factorial, which is 2 times 1, times, we still have our 3 factorial, which let us still retain our 3 factorial. Now looking at it, the 3 factorial can cancel out the 3 factorial, and what you have left is 5 times 4, that is 20, over 2 times 1, that will give us 2, and eventually we're having a 10 as the value of the expression here, 5 combination 3. So this is how you go about solving your combinations. I am quite aware that we have had to look at this, but this is just a refresher before we delve into what we want to do. So this concept of combinations features prominently in what we are studying when we want to expand binomials using combinations. All right, let's look at an example. Okay, say we want to expand something like this. Maybe say we want to expand a plus b raised to the power, let's say 4. All right, now I want you to take note of this. You are going to use combinations. Now remember that in our Pascal's triangle, we kind of looked at the rule, which is that the first term in your binomial, that is in this case a, will have to decrease from the given power 4 until you get to 0, whereas the second power, which is in this case is b, will have to increase from the power of 0 until you get to, in this case, 4. all right, that still remains the same for this particular method we want to look at. So our first term will always have to start decreasing from the given power until you get to 0. Then your second term would increase from 0 until you get to the power. That is one of the rules, so you have to note that. Now the second thing that you have to also note is that when it comes to the combination, your NCR, your n will have to be the power. Your n will have to be the power of the binomial that you want to expand. That is original power in the bracket, in this case 4. Now for your r, the r will have to increase from 0 until you get to n, in this case 4. So our r will have to increase from 0, the next one, so we're going to have n 4 combination 0, the next one 4 combination 1, 4 combination 2, until we get to 4 combination 4. Please note that. All right, at no point will the n, the value of n, change. It will always remain the given power, in this case 4. When we have raised to the power 5, our n will remain 5. So let us go ahead and see how we can use the concept of combinations to expand what we have here, a plus b raised to power 4. So we go ahead. The first thing that we have is a combination, so we're writing 4. Okay, so we have 4 combination 0. Okay, remember that is the first thing that we have. Let me make it a bit make it better. So we're having 4 combination 0. All right, then our first term is a. It will start decreasing from the power which we have, in this case 4, and our second term is b. It will start increasing from 0, plus the next for your combination. Remember that our 4 will remain unchanged, so we're still having a 4 combination, but in this case our r will have to be increasing, so the next will be 1. All right, we are going to 4. Our a now will be 3 because it is decreasing, while our b will increase to 1 plus. So I see that I hope you're getting the gist. So the next one, our 4 remains unchanged, so we're having a 4 combination 2 now. All right, and we have our a to be 2. We have our a to be 2, and our b has increased to 2 plus. Continue. All right, the next is still 4 combination. We have 3 now. Remember that our r is increasing and going to 4 combination 3. Our a in this case is 1, and our b is 3. Okay, okay, plus, and the last of it, we still have 4 combination 4. 4 combination 4, and our a has decreased all the way to 0, while our b has increased to 4. Okay, so that's our b has increased to 4. Please don't mind the writing. Okay, so the next thing that we have to do is to simplify all these combinations that we have. 4 combination 0, 4 combination 1, 4 combination 2, and we have also looked at before now how we also simplify this. So starting with 4 combination 0, remember that we have to use this general formula. Our n combination r is given by all this. All right, so we have to subtract the r from the n, find the factorial of that, and of course the factorial of the r. So we'll go ahead and implement all that here. What do we have? For 4 combination 0, that would give us, we have 4 factorial all over 4 minus 0 is still 4 factorial, and 0 factorial, r is 0 factorial, and of course we still have a raised to power 4 and b raised to power 0. Okay, over to the next one, that is the one here. So for combination 1, what would that give us? We have 4, using our formula for combinations, 4 factorial over 4 minus 1 factorial, that will give us 3 factorial. Okay, of course 1 factorial as well, because our r is 1. Then we have our a raised power 3 and our b raised power 1. I hope you're following me. The next one, we have for combination 2. How do we simplify this? That will still give us 4 factorial following our formula, that is n factorial now, 4 factorial over n minus r, that's 4 minus 2 will give us 2 factorial. Then we have a r factorial, which is still 2 factorial. In this case, of course, a raised power 2 and b raised power 2. Okay, we'll go ahead. Then we have for here, as the next one now, plus 4 combination 3, simplifying that will give us 4 factorial all over 4 minus 3, that will give us 1. So we're having a 1 factorial, then our r factorial, that is 3 factorial, then a raised power 1, b raised power 3, okay, b raised power 3. Then the last of them, all 4 combination 4, what does that mean? So we have 4 factorial all over 4 minus 4, that is 0. So we have n minus r to give us 0, so that's 0 factorial. Then of course our r factorial, which in this case happens to be 4 factorial. Let me make that legible. So we have 4, oops. Okay, so we have 4 factorial. Then we still have we'll have now a raised to power 0 and b raised power 4. So let me make demarcation so that we don't get confused of the levels. This is the first level that we've had. Now this is the second level now. Second level of simplification. Like scroll down a bit. So this is the second level of simplification that we are doing. All right, so let's go ahead and finally simplify what we have here. Now, looking at this, we want to take time and simplify each of these. All right, so for this one here, for this here, going ahead to simplify that, 4 factorial, of course 4 factorial will cancel 4 factorial, so you are left with 0 factorial, and 0 factorial means 1. I take that again. The 4 factorial, that is 4 times 3 times 2 times 1. In your denominator, you also have 4 factorial, 4 times 3 times 2 times 1. They're going to cancel out. Then you are left with 0 factorial, and 0 factorial is 1. So this expression here will simplify to 1. So 1 times a raised power 4 times b raised power 0. And remember that anything raised power 0 is 1. So what we're having is 1 times a raised power 4, which is a raised power 4 times 1. And everything here will simplify to give us a raised power 4. All right, you might want to watch that over and over and again to get to understand what we are saying. So simplifying this here will give us all this that we have here. All this will give us 1. B raised power 0 will give us 1. So we're having 1 times a raised power 4 times 1, and that will give us a raised power 4. You might as well go ahead and simplify that yourself to see how that works out. Okay, over to the next one. That is the one here. We have plus. Now 4 factorial. Remember that 4 factorial means 4 times 3 factorial, because of 3 times 2 times 1, that is 3 factorial all over. We have 3 factorial. Then your 1 factorial is simply 1 times 1. That will give us times 1. Then we'll still have a raised power 3, b raised power 1. All right. The next we still have plus. Then over to the next one, we have 4 factorial over 2 factorial over 2 factorial. Now remember that 4 factorial is 4 times 3 times 2 factorial, that is 2 times 1, all over 2 factorial times, and the other 2 factorial means 2 times 1. All right, and we have a raised to power 3, b raised to power 2. That is what we have. Okay, over to this one here, we'll still have plus 4 factorial, then over 1 factorial, 3 factorial. That will give us still 4 factorial means 4 times 3 factorial, all over 1 factorial, which is 1 times 1. That will give us 1. That will give us 1 times, we'll have 3 factorial. Let's maintain that so that I'm able to simplify. Then we have a sorry, I'm seeing a kind of mistake here. So here the value of our a has reduced. It's no longer 3. So here the power of a is not, the power of a there is not 3, rather it is 2. Okay, so like a check, all these powers must always add up. All right, so everything here must always add up to the initial power that you have, which is 4. All right, so 2 and 2 will give us 4. That tells us that we are correct. So the next power here, that will have a raised to power 1 and b raised to power 3. Of course, when you add the 2 powers, 1 plus 3, that will give you 4. All right, plus then to the next one, 4 factorial. So just like we did for the first time, now coming over here, let's simplify that straight away. So 4 factorial will cancel 4 factorial. All right, 4 factorial will cancel 4 factorial, and 0 factorial is equal to 1. So everything here will simplify to give us 1. And remember that also a raised to power 0 is 1. So what we're having is 1 times b raised to power 4, and that will simply give us b raised to power 4. And finally, carrying out our simplification, we have a raised to power 4. We have a raised to power 4 plus, then for here, the 3 factorial cancels the 3 factorial. So we are having 4 over 1, which will give us 4 a raised to power 3. B raised to power 1 is still b, plus over to this one, the 2 factorial here cancels the 2 factorial here. So we are having 4 times 3, which is 12. So 12, and under here we're having 2. So 4 times 3 is 12 over 2 times 1, which is 2. 12 over 2 give us 6. So we're having 6 a raised to power 2 b raised to power 2. All right, plus over here, the next one here, the 3 factorial cancels the 3 factorial. So we're left with just 4 over 1, and 4 over 1 will give us 4. Now a raised to power 1 is a, and b raised to power 3 is b raised to power 3, and finally plus here, which is b raised to power 4, b raised to power 4. So this that we have here, all this that we have here, that is the expansion of a raised to power 4. Now let me quickly show us something. All right, note the equation that we have. Mind you, the equation that we have for a raised to power 4 here is 1. For here we have 4. Please note that. For here we have 6. For here we also have 4, and for here we also have 1. All right, so let us let us look at something. All right, so let's try to draw a Pascal triangle for the power of 4. Remember, if we want to do that, we have a 1, we have a 1 and 1, starting with 1. 1 plus 1 will give us 2. We'll write a 1. Start with 1. 1 plus 2 will give us 3. 2 plus 1 will give us 3. We have a 1. And the next one, start with a 1. 1 plus 3 will give us 4. 3 plus 3 will give us 6. 3 plus 1 will give us 4. And we have a 1. Can you see something? Now these coefficients that we have here, remember that we wrote them out. That is all this. So all this. So we're having, look at the 1 here. look at the 4, look at the 6, look at the 4, and look at the 1. So what are we seeing? So it simply means that all these combination values that we have, the 4 combination 0, 4 combination 1, 4 combination 2, 4 combination 3, and 4 combination 1, that they are representatives of the coefficients that we have in the Pascal's triangle for 1, 4, 6, 4, 1. And this holds for every other value in our Pascal's triangle. So when you want to draw, okay, let's say that I want to continue this and draw up to for 5, that will give us 1, 4, 1 plus 4 will give us 5, 5 plus 6 will give us 10, 6 plus 4 will give us 10, 4 plus 1 will give us 5, and then 1. So if we have an expansion to do, maybe say a plus b raised to the power 5 using our combinations. So when we start writing all those 5 combinations, 0, 5 combination 1, 5 combination 2, 5 combination 3, all the way up to 5 combination 4, 5 combination 5. So one way to check your answers is that all these 5 combinations, 0, 5 combination 1, in this case, they must always evaluate to these coefficients that we have here. So your 5 combination 0 must evaluate to 1, your 5 combination 1 must evaluate to this 5 here, your 5 combination 2 must evaluate to this 10 here, your 5 combination 3, go ahead and try that out, must evaluate to 10, your 5 combination 4 must evaluate to 5, and then, oh, there's a mistake here. So this 4 here, so 5 combination 5 must also evaluate to 1 as you have it. So this would be like a kind of a check for you. So you can just go by the side and draw out your Pascal's triangle, note the coefficients, and then you go ahead to run your combinations, simplify them. Bear in mind that you are supposed to get these coefficients when you simplify these given combinations, and then you go ahead and still implement the rule, which is that the first term of your binomial expansion must start decreasing from the given power to 0. The second term will also start increasing from 0 till you get to the given power. And of course, when there is a negative sign, just like we've studied in the previous videos, when there is a negative sign, that negative sign must always be included in the brackets. Okay, and when you have like a coefficient for the terms, for example, maybe say we will have something like this, a plus 2x. Okay, let's just look at this example. So let's say you want to solve a plus 2x raised to power 3, all right, using combination. So I want to use the method of combinations to expand this a plus 2x, or let me even make it a minus now. Let me use minus in this case. So a minus 2x raised to power 3 using a combination. So let's go ahead and look at this so that will kind of solidify what we're doing. So remember that we are to use our combinations, and the first thing that we need to do, the power is 3. That means our n in this case is equal to 3. So our n is equal to 3. It will remain unchanged. However, your r will start increasing from 0 until you get to 3. So we have the first one, which is 3 combination 0. We have a raised to power 3, then the bracket minus 2x. Remember, you must always include in bracket raised to power 0 plus, all right, plus the next we'll still have 3 combination 1, and we'll have a raised to power 2 in bracket minus 2x minus 2x, please pardon the minus 2x raised to the power 1 now, plus we'll have the next, which is 3 combination 2 now, and we have a raised to the power 1 now, and we have a bracket minus 2x raised to the power 2, and the final one will still have plus 3 combination. Oops, that 3 is it's supposed to be a superscript, so 3 combination 3 now. So we have a raised to the power 0, and in bracket minus 2x, oops, minus 2x raised to the power 3. All right, this is what we have. So let's go ahead and simplify this now. Let me change the color of the marker. So we have this. Let's go ahead and simplify that. 3 combination 0, you can be sure would give you 1, but let's see how that works out. So 3 combination 0 will give us 1. That is 3 factorial all over 3 minus 0 factorial, which is 3 factorial. Then you have 0 factorial, and all this will give us, evaluate to 1. We have a raised to the power 3, and we have a minus 2x in bracket raised to the power 0, which will still give us, which will all evaluate to 1. That is this one here. A minus 2x in bracket raised to the power 0 will give us 1. All right, that is that. Now looking at the power of this here, the power of our minus 2x is an odd number. That means the minus here will not be cancelled out, and minus here times the plus here will give us a minus. So the next sign is going to be a minus. All right, now 3 combination 1, that is 3 factorial over 3 minus 1 factorial, that is 2 factorial, times our r factorial, which is 1, because 1 times 1 is 1. Then we have a raised to the power 2, and of course your 2x raised to the power 1 will still give you 2x. All right, the next will come over here. Now look at the power here. The power is 2. That means that this minus in the bracket here will be cancelled out, so we're going to say retain the plus sign. Now 3 combination 2 now, that means 3 factorial all over 3 minus 2 factorial, that will give us 1 factorial, which is 1, times also 2 factorial, because our r is 2 factorial, so we have the 2 factorial there. Then simplifying this, our a raised to the power 1 is a, and then our 2 raised to the power x, 2 squared is 4. Remember that 2 squared, because the power is going to affect everything in the bracket. So 2 squared is 4, and x raised to the power 2 is x squared. All right, then the final one, which is this, let's also see how that works out. So 3 combination 3 will give us 3 minus, that is 3 factorial all over 3 minus 3, that's 0, so we have 0 factorial. Then our r is 3 in this case, which is 3 factorial as well, and as you know, all this will evaluate to 1 eventually. Then we have times the a raised to the power 0 here is 1, anything raised to the power 0 is 1, so we have 1. But even at that, look at the power here. The power here is negative. That means that this minus sign here would still hold sway. So minus times plus, so the sign that we're supposed to have is minus sign. All right, then trying to simplify this, 2 raised to the power 3, that is 8, and x raised to the power 3 will give us x cubed. Okay, now finally simplifying all this now, trying to simplify this that we have here. 3 raised to the power 1, 3 factorial now over 3 factorial will cancel out, 0 factorial will give you 1. So everything that you have here will evaluate to 1. Everything that you have here will evaluate to 1. So 1 times a raised to the power 3 times 1 will give us a raised to the power 3. minus over to this side here. 3 factorial will give us 3 times 2 times 1, which is 6, all over 2. 6 over 2 will give us a 3. So we have a 3. Now look at what's going to happen. This one here, the whole of this will give us 3, and we have another, we have a 2 here. Remember that they're multiplying, so 3 times 2 will give us a 6. All right, so what we're having here is 6a squared x. That is what everything here will evaluate to, 6a squared x. Over here we have plus, that is this one here. Let's try to simplify that as well. Now 3 factorial, remember it is simply 6. 3 times 2, 6 times 1, 6, over 2 factorial is 2, so 6 over 2 will give us 3. So this here will evaluate to 3. Now we are having a 4 here, so 3 times 4 is 12. So we have 12 a x squared. All right, and lastly we have this one, which is minus in this case. Now all this here we evaluate to 1. It was 3 factorial, we'll cancel 3 factorial, so you have 0 factorial. 0 factorial is 1, so 1 over 1 is 1. 1 times 1 is 1. 1 times 8x raised to the power 3 will still give you 8x raised to power 3. And this here will be the answer to the expansion that we have here. This. Now you might go ahead and utilize your Pascal's triangle, and you would see that you also get this. So that's one of the things that you want to try out to make sure that you are at home with this topic. So this is basically what the binomial expansion is all about, using your combinations. Okay, so what thing that we need to do is that we need to really understand how this formula works. N combination R, which is given by n factorial over n minus r factorial r factorial. So we need to really pay attention to how this works, and then use it to expand the combinations. Remember that your power, your n, will remain unchanged. However, the r will increase from 0 until you get your n. Simplify that, then note that the first term of the binomial will decrease from the given power, while the second term of the binomial will increase from 0 to the given power. And of course, mind your negative signs where you have a negative sign, and where you have a coefficient and a term, make sure you enclose them in a bracket and allow the power to also affect the terms that you have in a bracket. All right, and when you do that, I'm sure that it will come out fine. Okay, so let's take down the following as practice. So practice the following. Try to expand these using not partial triangle now, but using this method of your combination. So try to expand this, trying to expand this. So for starters, try to expand a plus b now raised to power 6. Try to expand this using the method of combination, and a little bit of the advanced one. Try to expand this now. 2x minus 3y raised to power 4 using the method of combination. And the last one, also try this out. Try to expand 2a minus y raised to power 5. All this should be done using the method of the combination. So do this and then get back to me, so that, and if there's any question or any concern, you can also reach out to me and we'll take it up from there. Until the next class, I'll be seeing you. Bye. Take care of yourself. Stay safe, please. Okay.